So as we look at probability 26A, you just need to know as we start this one, it's a very long and complicated problem. It's going to require an extra piece of paper. So find a blank piece of paper because we're going to start on this problem by making a tree diagram that gets pretty complicated because we're looking at what's called a best of three series. When you play like a playoff series in the best of three games, a team has to win two games to win the series, and sometimes you can win that in the first two games, or sometimes it takes three games to do that. So we're going to look at this set of probabilities, and in this case it's been determined that one of the teams is apparently better than the other, or at least has been better than the other, and so they are given a 3/4 chance of winning, and that would be the Sparrows. So we have the Sparrows versus the Crows. So to make my tree diagram, I'm going to start with two branches, one thinking of the Crows winning and the other thinking of the Sparrows winning, and we think of this as like the first game. So in the first game, the Crows or the Sparrows can win in the first game, but the probability is not equal because one of the teams is apparently considered to be much better than the other. It's like the champion of the league versus a lower seed or a lower ability team. And so the Crows we think of as a 1/4 chance if the Sparrows are 3/4 probability of winning the game, first game. So there's the first game, and we don't know how the outcome comes out, so we have to assume that a second game is played, and even if one team or the other won the first game, there still would need to be a second game played. So in this case, we think of the Crows again and the Sparrows playing that second game. So there's my second game. And again, it's 1/4 and 3/4 for the probability. Or if the Sparrows had won the first game, we still have the Crows and the Sparrows playing in that second game, and it's still a 1/4 and 3/4 probability for that second game. So I'm just building the tree right now, trying to think of all the different possible scenarios or outcomes of this series. And so once we get to the third game, in some cases there's no third game that needs to be played because if the Crows win the first two, then this branch is finished. There's no reason to continue on, and so that branch ends. But if the Crows win, then the Sparrows win. We still have to go one more game in this branch, and this is the third game now, if the third game is necessary. And again, the Crows could win or the Sparrows could win, and our probabilities are in 3/4. And if we look at this lower branch, lower set of branches, again, if the Sparrows won, then the Crows won, then we'd have one more game with the Crows and the Sparrows, and the 1/4 and 3/4 chance of teams winning. And again, the bottom branch, if the Sparrows win the first two, then that branch is finished. And so they had won the series. So in some cases you have to go all the way to 3 games. In some cases you can just play 2. So now what we want to do is look at all the outcomes and all of their probabilities. And again, this is a very complicated system, but we can hopefully make some sense out of it by just taking each branch, like in this case, this branch. The Crows win the first two, and it's 1/4 times 1/4, or 1/16 chance of that happening based on the probabilities here. 1/4 times 1/4. If we just take the next branch, the Crows, then the Sparrows, then the Crows, Crows, then the Sparrows, then the Crows, and the probabilities, 1/4 times 3/4 times 1/4 equals 3/64. 1 times 3 times 1 is 3, 4 times 4 is 16, times 4 is 64. So there's the probability for that scenario or that situation taking place. Then the next one, the Crows, then the Sparrows, then the Sparrows again. And looking at the probabilities, 1/4, 3/4, 3/4. So 1/4 times 3/4 times 3/4 equals 1 times 3 times 3, which is 9, 4 times 4 times 4, which is 64. So 9/64. Again, that's a more likely outcome because the sparrows supposedly are better chance of winning. So let's continue. Now we're on to the bottom branch. If the sparrows had won the first game, and then we move along to the crows and then the crows. So sparrows, crows, crows. And the probabilities are 3/4 times 1/4 times 1/4. Or in this case, 3 times 1 times 1, which is 3. 4 times 4 times 4, 60/4. And then the next branch, sparrows, then crows, then sparrows. And this times 1/4 times 3/4. So 3 times 1 times 3, or 9/64. And then the very bottom branch, where the sparrows just won 2 in a row, or 3/4 times 3/4, which is 3 times 3 is 9 over 16. And that is the most likely outcome, again, because the sparrows have the advantage apparently, and so more likely to win. And so you get the largest probability. So here's all our probabilities for the different outcomes or different ways this 3-game series could end up. 1/16, 3/64, 9/64, 3/64, 9/64, and 9/16. Now I'm going to actually change all of these to 64s because I'm going to need that in just a moment to compare. But 1/16 is 4/64 because we have to multiply 16 times 4 to get 64. And 9/16 is 36/64 because 9 times 4 is 36 and 16 times 4 is 64. So again, you can see that this outcome, 36/64, is the most likely outcome in the set. It's a little bit more than half of the time that we would expect this outcome to be the case. Now we did all of those outcomes in order to answer some questions. So if we're just trying to figure out the chance or the probability of some different things happening. So what if we said, what's the chance of the sparrows winning in 2 games? So if we look at this one here, this is the one situation where the sparrows win it in 2 games. They play 2 games, they win the whole thing, and that's the 9/16 or 36/64. So I'm just going to write it in the simplest fraction that we have is the 9/16. That's the probability. In fact, more than half the time you would think in a 3-game series, that they would win in the first 2 games, be done. But then we could ask the question, well, what is the probability that they win? It takes them 3 games to win a series. And there's actually 2 scenarios where that would happen. There's this one, where the sparrows win in 2 games, or in 3 games, but you have to win 2. So there's the 2 they win. They lose the first one and then win the next 2. Or, in this case, they win the first one, lose the second one, and then win the third one. So it takes them 3 games to win it. And if you look at the probabilities, 9/64 and 9/64 for each one of those. So you add 2 together. So I need to add the 9/64 and the 9/64 so that I get 18/64. And I'm going to reduce that fraction as much as I can. In this case, they're both divisible by 2, so that's 9/32. So that's the probability they win in 3 games. It takes them 3 games. And you can see that that's a little bit, it's right around 1/3 of the time, a little bit closer to, not quite as much as the first one. So they still have a pretty good chance of winning a series in 3 games. And then if we actually ask one more question, well, what's the chance of them just winning the series in general? So really, there's 3 ways they could win the series. They could win it this way, or this way. So we take all 3 of those and put them together. And that's why I actually wanted this in this terms, because now we need this one, and this one. 9/64, 9/64, and 36/64 all put together. So we've got to put all 3 of those fractions together. 36 plus 9 plus 9. So we have all of those. And I'm actually going to write it out so we can see what we're doing here. We have 36/64 for the one, and then 9/64, and another 9/64 for the other 2 probabilities. And so put that all together. 36 and 9 is 44, 45, and then 54 out of 64. And that fraction reduces to 27/32. So pretty high likelihood that the Sparrows should win the series based on their probability of winning that. So, well, let's look at the other end of that. So what's the probability that the Crows actually win this series in 2 games? So there's only one scenario for that. And that first one, the 1/16, 1 out of 16 chance, compared to the Sparrows that had a 9 out of 16 chance of doing that. We saw that. So much more likely, in this case, not very likely here, to win it in 2 games, to win the first 2 games and be done. Or what about to win it in 3 games? So again, there's 2 ways that the Crows could win it in 2 games. There's this one in 3 games. It's this one. And there's this one. So here they win it in 3 games, 2 times. They win the last 2, or they win the first and the last. And so we have in here. So we have these 2 that go together. So 3/64 and 3/64, or 6 out of 64. Or we can divide both of those by 2 and get 3 out of 32. So you can see that's not real likely that they'll win in 3 games either, and so then we ask the final question, of course, what's the probability that they actually win the whole series? And so we have all of these probabilities to put together. We have the 4/64 that they do it in 2, so we have this one now to put together with these other 2. So I'm going to actually go ahead and write them all out here like I did in the other one. So we have the 4/64 plus 3/64 plus another 3/64. So we're just adding all of the different possible ways they could do this together. So 7, 3 is 10/64 that they win the whole series. That reduces to 5 out of 32. And really, we could have picked that up from up here because the probability of the Sparrows winning is 54/64, or 27/32. And so this is the rest of it, the 10 more, 10/64, or 5/32. Again, not very likely for the Crows to win the series based on this scenario probabilities. And again, I told you this was a long and complicated problem, lots of work to do, and it all depends on getting this tree diagram right to begin with. Understanding multiplying across and then adding probabilities together that are necessary to find the combinations of scenarios that work in this situation. So that's doing a 3-game best of 3 series, determining probabilities for each event.